All right, so we are looking at 8.4, the binomial theorem, day one, and we're going to start with binomial coefficients. Now, just remember that a binomial is a polynomial with two terms, and we want to look at an easy way to find the coefficients of each of those terms when we have to expand x plus y to a large exponent, or even to to an exponent that's not that large. We can make our lives a whole lot simpler by using binomial coefficients. So just take a look what we have here. We have row 0, which is it just raised to the 0 power. Anything to the 0 power is 1. Row 1, well, nothing much happens here because it's just to the first power, so you just leave it. Here, remember, when it's to the second power, what you're going to do here is you don't distribute the exponent because of the plus. This means you're going to multiply out two of them, and then you're going to FOIL. And when you do that, you end up getting this. The third row, now you're going to multiply out three of them. So first you would FOIL out these two, and then once you have the answer, you'd multiply out a third one. And if you were to do all that, you'd end up with this answer, and then to the fourth power, fifth power, and sixth power. Now clearly you can do this by hand, but you'll notice we're getting these coefficients right here, and those are going to start to get bigger and messier, and it's going to be easier to make silly mistakes and get wrong answers. And we're going to use the binomial theorem to help us today. So first of all, what you should notice are some patterns. There are n plus 1 terms for each row n. So for example, this is my fourth row. I have 5 terms. 1, 2, 3, 4, 5. The 0 row, I have one more than that, 1 term. Second row, I have 3 terms. 1, 2, 3. Notice for the powers of x decrease, powers of y increase. So when the powers of x decrease, notice that what I mean by that is we have x cubed, x to the second, x to the first, x to the 0. Then we have powers of y increasing as you go to the right. So in other words, this is y to the 0, y to the first, y to the second, y to the third. Let's take a look at this row and look at x and y. You have x to the fifth, x to the fourth, x to the third, x to the second, x to the first, x to the 0. Here you have y to the 0, y to the first, y to the second, y to the third, y to the fourth, y to the fifth. The next thing you should know is that the sum of the powers for each term is n. So if you look at the variables, notice that the exponents add up to n. So for example, I'm in the fifth row. This adds up to 5. There's a 1 here. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5. And this is 5. In the second row, this is 2. These are each 1, so 1 plus 1 is 2, and this is also 2. And the last thing you should notice is that the coefficients in each row increase and then decrease symmetrically. So in other words, notice it goes 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. In other words, it increases and then it decreases the exact same way that it increases. When you have an even number of terms, same thing. 1, 5, 10, 10, 5, 1. All right, so now the binomial theorem, what it does is describe the coefficients. We use this C right here, and it's very important to use a C. We're going to talk about P later when we talk about permutations. Right now we're looking at combinations, and this is the notation you use. N stands for the number of terms, and actually we're going to say it's the number, well, we could say terms, but we can also say number of terms or rows. And then this is the number of term in a row. Number of a term in a row. So notice we have n. This is pronounced n choose r. Although your book doesn't use the word choose, it's just the way I learned it. So you have n and r. This is not a fraction. This means n factorial over n minus r factorial times r factorial. So it looks something like this, and I know this seems confusing, but just bear with me here. So we have, this is the 0 row, first row, second row, third row, and so forth. Then we have a 0 term. So this 0 row has the 0 term. This has a 0 term, a first term. Second row has 0 term, first term, second term. This has 0 term, first term, second term, third term, and so on and so forth. So this is the formula you use to figure out the coefficients when you are multiplying binomials. So take a look at here. Let's just look at this formula a little bit more. So this n is the row, r is the term. So we always start counting with 0. If you look on page 603, you'll see this table. What this means is if you were to go 4, choose 2. So in other words, fourth row, second term, you would get a 6. If you were to do second row, second term, you would get a 1. And just to show you how this works, here's the fourth row, third term. If I follow my formula here, so this is 4, this is an example then. 4, choose 3. This is the same as 4 factorial over 4 minus 3 factorial times 3 factorial. And then this becomes 4 times 3 times 2 times 1 over 1 factorial times 3 times 2 times 1. Well, remember, we learned 1 factorial is the same as 1. These cancel out, and all you're left with is 4 over 1, which is equal to 4. And that's exactly what we were supposed to get. So if I were to use this formula for 2 choose 1, I would end up with 2. If I would go 4 choose 1, I get a 4. 1 choose 0, I get a 1. Just to remember, another remember here is that 0 factorial is equal to 1. Okay? All right. So moving along here, let's try to do some of these. So we want to try these out. When you write it like this, it's the same as going like that. So in other words, this is the same as 10 choose 8. It's the same thing. It's just two different ways of writing it. So if we use our formula, I'm going to go 10 factorial over 10 minus 8 factorial over 8 factorial. And this is 10 times 9. And I'm actually going to stop right here, and you're going to see why in a second, over 2 factorial. And look at this. The 8 factorials, they're gone. So now you have 10 times 9 over 2 times 1. And the 2's cancel, and you end up getting 45. And if you were to take your calculator, and I'll show you how to do that in a minute, you get 45. So now we have 12 choose 5. So we're going to go 12 factorial over 12 minus 5 factorial times 5 factorial. And we'd have 12 times 11 times 10. While I'm writing this out, just if you want to, folks, you can stop the tape right now or stop the podcast, try these 4 problems and see if you're getting the same answer that I am, and then press the tape again when you're ready to keep going. And then this would all be over 7 factorial times 5 factorial. Actually, I'm going to change one thing up here to make my life a little bit easier. I've noticed I have a 7 factorial down there. So let's just do this. So now this is times 7 factorial. So this cancels this. And then here I end up with, let's do a little more erasing so it gets more room. And so we end up with, we still have 12 times 11 times 10 times 9 times 8 all over 5 times 4 times 3 times 2 times 1. If I go 4 times 3, that cancels out the 12. 5 times 2 cancels out the 10. And all I'm left with is 11 times 9 times 8 over 1. And I'm going to use a different calculator here just because it's instead of waiting for the other one to warm up. So 11 times 9 is 99 times 8. And I end up getting 792. And if you were to take your calculator, you'd get the same answer. And again, I'm going to show you how to do it in your calculator in just a second. So here we have 9 choose 4. So we're going to take 9 factorial over 9 minus 4 factorial times 4 factorial. So we have 9 times 8 times 7 times 6 times 5. I'm going to stop here. You'll see why. So we have 5 factorial over 4 factorial. So this cancels this. And now I have 9 times, let me draw one under here so you don't get mixed up, times 8 times 7 times 6 all over 4 times 3 times 2 times 1. Well, I got a couple things I can do here. I think I'm going to go 4 times 2 is 8. 3 can go into 3 once. 3 can go into 6 twice. So we have, and this is just a 1 on the bottom, 9 times 7 is 63 times 2 is 126. And we'll go one more here. So we have 14 factorial over 14 minus 12 factorial over 12 factorial. This one's actually going to be much easier than it looks at first, because all kinds of stuff is going to go away. So we have 2 factorial times 12 factorial. This cancel each other out. Remember, 2 factorial is really 2 times 1. And 2 can go into 2 once. 2 can go into 14 7 times. 7 times 13 is 91. Okay, just go like that. All right, now I keep talking about how to do this on your calculator. What you're going to do is you're going to go press menu, and then you want option 5, which is probability, and then go to option 3, which is combinations. Permutations, which we're going to talk about later, and then this is one way to access factorial. Another way to access factorial is to press this button right here, and you'll get 8 different options. I kept thinking it was under the pi button. I told one of my classes that, but that's incorrect. You want this button right here. There even is an exclamation point on it, or you can access it this way. It doesn't matter. This is probably a much faster way. So anyways, menu, option 5, option 3. And when you type that option 3, NCR pops up. And if you type it in like this, that's wrong because you have to have the largest number first, okay? You can't have the smaller number first. Because what this is saying is the 12th row for 14th term, and that simply does not exist. 12th row, or not room, sorry about that. 12th row, 14th term doesn't exist. Okay, it's not that there's no solution, it doesn't exist at all. And so what you need to do is you go 14, 12. Remember back here, when I did it, let me go back another page, I got 91. There it is. And when I checked it on the calculator, I got the same thing. I got 91. Just notice you do the larger number, comma, smaller number. Okay, so it's NCR. And I'm sorry, there's no equals, it's just a parentheses. And that's how you enter it. Okay? All right, now let's say we wanted to multiply this. We want to use the patterns to multiply this out. Well, if we go back to our notes here, remember, if we go to the 4th row, I had this written for you. Go back, sorry about that. Here we go, 4th row. Notice the coefficients go 1, 4, 6, 4, 1. And this is on your book on page 603. So that's what I'm going to start with. So we're going to have 1, 4, 6, 4, and 1. So it's x to the 4th. So remember, we go decreasing exponents for the x for the first term. So this is x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0, which is just 1. And then we're going to have y to the 0, which is 1, and then y to the 1st, y to the 2nd, y to the 3rd, y to the 4th. So our final answer is right here. There you go. If I had multiplied this out 4 times, I probably would have made a lot of mistakes, and I did this much faster, and I got it perfect. Okay? Now, what happens when there's a minus and there's a 2 here? So far, all of our coefficients for these problems that we've been using have been 1. Well, we're going to actually do the exact same thing. So if we go to the 3rd row, if I go back a few pages again, my 3rd row is 1, 3, 3, 1. So that's what I'm going to start with. That hasn't changed. So I'm going to write 1, 3, 3, 1. Well, so I have x to the 3rd. So far this hasn't changed. We have x to the 3rd, x to the 2nd, x to the 1st, and then x to the 0, which is 1. Now, I don't have a y here. I have a negative 2y. Okay, so what I'm going to do is this. I'm going to say my x is x, and then my y is negative 2y. Because now watch what happens. So we have negative 2y to the 0. Well, that doesn't change anything. Here I'm going to have negative 2y to the 1st power. Here I'm going to have negative 2y to the 2nd power. Here I'm going to have negative 2y to the 3rd power. Okay? So in other words, if we simplify this, I have x to the 3rd, and then I have 3x squared, and I'm going to put a times negative 2 times y, 3x, so negative 2 squared is positive 4, and then y squared, and then we're going to have one we don't have to do anything with. Negative 2 to the 3rd is negative 8, and then y to the 3rd, and then so I have x to the 3rd, and this becomes minus 6x squared y plus 12xy squared minus 8y cubed. Okay, notice how much faster this was. I should say less messier it was than multiplying this out 3 times, because I guarantee you most of my students multiply this out, they make mistakes because they make negatives disappear. Now it's possible you could have gotten the right answer if you had just gone ahead and multiplied it out with brute force. But once you get the hang of this, this method really goes much faster and you're much less likely to make mistakes and small errors. All right, so now just a couple of homework hints. For 37 and 41, note that it's the variables that are squared. So this was number 37. So you have decreasing orders of this first term. So first we have 1, 4, it's for the fourth row. So it's 1, 4, 6, 4, 1. That hasn't changed. And I'm sorry I wrote this in a backwards order, but you have x squared. So we're going to have that in decreasing order of exponents. So x squared raised to the fourth, x squared raised to the third, x squared raised to the second, x squared raised to the first, and x squared raised to the 0. It's the same thing here, except you have x squared. You don't have x. And then we're going to take 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and then you simplify everything. So 41 will be the same idea. And then don't worry about these two problems yet. This is for tomorrow's assignment, and we will talk about that tomorrow. If you have questions, please send me an email over the weekend, and we will finish this up on Monday.